Hey everyone, hey Valen, thanks for having us today. Uh, Thank you all for joining us for this new public webinar about Azure Network Security. And my name is Gustavo Modena. I'm a product manager in the customer experience engineering team. And joining me today, I have Mathu, who will be helping with the session for what's new in Azure Firewall. Uh, during this session, we're gonna have this agenda. So this is what we have planned. So we are going to do an overview of Azure Firewall and its capabilities. We're gonna briefly talk about use cases, and then we will start talking about the features. We have separated the features in two sections here, one for monitoring and the other one for management. And towards the end, we're gonna have a demonstration showing a little bit more about these new features. During the session, feel free to ask your questions in the chat. We have a team here so they can help answering any questions. If we are not able to answer all the questions in the chat, we are planning to have a Q&A session at the end as well. Okay, so let's start with the overview of Azure Firewall, right? So the Azure Firewall is our first party or our cloud native firewall in Azure, right? It's a next generation firewall built with built-in high availability and unrestricted cloud scalability. So it works as active instances, and the number of instances is scale out based on the utilization of the Azure firewall. So customers really don't need to do any kind of intervention to deploy new instances as the consumption of the Azure firewall goes on. Azure Firewall today is offered in three different SKUs, which is basic, standard, and premium. The basic is intended for small customers that doesn't have a lot of requirements, like for example using advanced features like IDPS and threat intelligence. But even though it's intended for small customers, there are also enterprise customers using it for small line of business and some other applications. Then we have the standard SKU, which is our first version of the Azure Firewall released a few years ago. It has network rules, application rules. It brings threat intelligence as well. So we also can use web categories in the standard SKU. And then we have the premium SKU, right? Where the premium SKU introduces the TLS inspection at application rules level. Then we have the IDPS, which is the intrusion detection prevention system. That's also only available for the premium. We have the URL filtering, so we can be very specific on the URLs that we want to inspect and apply filters on. Then web categories, we can also use URL filtering for web categories. The Azure Firewall, is available in two different deployments today. You can deploy the Azure Firewall in a VNet, or you can also deploy Azure Firewall in a hub VNet using vWAN. And when you deploy the Azure Firewall, it helps you inspecting traffic, between hybrid networks. Let's say, for example, on-premises in Azure, external clouds in Azure, or even, between different VNets on Azure. And so it helps inspecting the traffic, east-west traffic, north-south traffic for your entire network. This is just a diagram really showing, how to implement the Azure Firewall, like a topology, right? So you could have your Azure Firewall in a hub VNet. So let's say, for example, we have a hybrid network where we have our on-premises network connecting to Azure via VPN tunnel or even express route connection. And then all the traffic coming from on-premises to Azure is going to be inspected by Azure Firewall. So we can have the Azure Firewall in a hub VNet, where all the traffic coming from on-premises or even, like I said, internet or third-party clouds would be inspected. And once the Azure Firewall inspects the traffic, it will be sent to the other networks on Azure. Um, there are different implementations where customers are also using Azure Firewall in spoke VNet, so they can have multiple layers of inspection. And in these cases, it's more like a combination, right? So what Azure Firewall you're using to inspect traffic from hybrid network, and what Azure Firewall you're using for internal traffic. When you're using the virtual hub or the secure hub with Azure Firewall, then the topology changes a little bit, because the hub VNet will be hosted by the virtual WAN, so in the virtual WAN solution. But at the end of the day, the topology looks pretty much the same, right? So we have a hub VNet and an Azure Firewall deployed at hub VNet, and then inspecting traffic between different networks, or even between networks on Azure. Okay, so let's start with the monitoring features. We did have some announcements published in our tech community blog for that Azure Network Security yesterday, and this feature is one of the new announcements. So flow trace logs was previously released in public preview, and yesterday it was announced in general availability. So the idea of the flow trace logs is really to show all the packets within a flow. So let's say, for example, when we have a VM connecting to a server via Azure Firewall, and then we want to see exactly what are the packets going through between those two VMs. So if we check the network rules or the application logs, network logs or application logs, we will only see the first packet hitting the rule, right? We are not going to see any CNAX, anything, any reset packets, anything like that. So sometimes when we have asymmetric routing, it was a little bit tricky to troubleshoot that, because Azure Firewall was not showing any kind of additional flow. So let's say, for example, we would see maybe the first packet going through, but we will not see the subsequent packets because they are not showing on the network or application logs. So with these flow trace logs, we can really troubleshoot a little bit further when we have scenarios where, let's say, for example, the first packet between VM-A and VM-B is not going through the Azure Firewall, but then the VM-B has a route to return the traffic through the Azure Firewall. What's going to happen in that scenario is that the Azure Firewall, once it receives the returning packet, it will try to find a state for that flow. And since it has never seen the first packet or the SYN packet coming through it, it will just drop the CNAC. And once it happens in these new logs, we're going to see the dropped packet marked as invalid. So here we can see what are the flags that we are expected to see in the flow trace logs. So we're going to see CNAC packs, FIN-ACK, reset, and invalid. And again, just reinforcing that the invalid is for packets that have been dropped for example, in asymmetric routing issues. So it's a really nice feature. We have received a lot of good feedback on that, especially from people troubleshooting network issues and connection issues. We are happy to announce that this is now general availability, and another feature that really empowers the administrators troubleshooting and managing Azure Firewall today. So next feature that we have here is the Azure Firewall embedded workbook, right? So first thing is, what's a workbook? So workbook is a resource in Azure that allows you to create reports by using logs that you send to Log Analytics workspace, right? And then you're going to create these reports by using custom queries, and then you can just create whatever you want. any kind of reports you want based on the logs that you have available. We used to have, actually, we still have 3 workbooks for Azure Network Security products in our GitHub. Azure Firewall used to have the workbook in this GitHub, so customers could go and deploy the workbooks themselves. But every time that we had a new update, customers will need to go to the GitHub and redeploy the workbooks again. So with this new feature, what we are doing, we are really bringing the experience of having the workbook directly in the Azure portal. So when you go to your Azure Firewall resource, on the left side, you're going to see a monitoring section, and then you're going to see the workbook available there. When you click in the workbook, you're going to see an option to open the workbook for Azure Firewall using structure logs. And that's an important point here because the embedded workbook is only supporting, is only available, that's the right word, it's only available for structure logs. If some reason you haven't migrated from diagnostic logs to resource-specific logs, and you are not able to migrate it, then you need to keep using the workbook that's available in our GitHub. But then if you have moved it to the structure logs, no need to deploy workbooks anymore. It's available right in the portal, so you just need to have your diagnose settings enabled, sending all the logs to a log analytics workspace. And then you go to the portal, open the workbook, and you have all the predefined dashboards and charts available in the workbook. One thing that it's really important to mention here is that we now have a new tab in the workbook for Azure Firewall, which is the Threat Intelligence tab. It wasn't available previously, but we now have a dedicated section only for Threat Intelligence. Here in this picture, we can see just an idea of what charts we have. So you're going to be able to see what has been denied or not. You also have the information based on protocols and a lot more information. We're going to have a demonstration about this later today in this session. So I'm not going to talk much more about this. So yeah, that's it for the embedded workbook. It's available right in the portal. No need to deploy it anymore. Really easy to start using. The most important thing here is if you haven't started using resource-specific logs, migrate, and then you're going to start using these easily. Then next one is the resource health, which is a feature in public preview. The resource health is not really a new resource for Azure. That's been there for a long time for other resources, but it's now available for Azure Firewall. There was no integration between resource health and Azure Firewall, and since I would say 3 or 4 months back, we have this integration with Azure Firewall. What's the benefit of having the resource health integration is that you can see the health history of your deployments, and then when we have these events available here, you can see if something affected the health of your Azure Firewall deployments, and then you can correlate these to users complaining about connection issues or any kind of support cases that you have on your side. There are 2 types of events, in the resource health that you're going to see. One is platform and the other one is non-platform events. The platform events are usually caused by the Azure infrastructure issues, and the non-platform events are caused by user actions. So a misconfiguration or something that could cause Azure Firewall health to, Azure Firewall to go unhealthy would be marked as non-platform issues. The health history here will be available up to 30 days in this in this view. So you can see the root cause analysis report for any platform-initiated unavailability events. Okay, so now moving on to the management part of this session. We're going to start with IP group limit increase. So this is not really a feature that's available in the portal or via infrastructure as a code. That's a change on how many IP groups we can have attached to a single Azure firewall, right? So the previous limit was 100 and the new limit is 200. Just before we talk about the group limit, what is or what are IP groups, right? So an IP group in Azure is an Azure resource that allows you to group and manage IP addresses for Azure Firewall, in different ways. So you can have like IP groups in DNet rules or source address. You can also have IP groups as source and destination addresses in network rules, or you can have it as a source address in application rules. An IP group can have, single IP addresses or multiple IP addresses. It can have also, one or more IP address ranges, or you can also have a combination between IP addresses and IP ranges. And the advantage of using IP groups is that you can reuse the IP groups in Azure Firewall, DNet network, and application rules for multiple firewalls across regions and subscriptions. So it makes really easy to manage network or firewall rules when you're using the IP groups, because then you just need to make changes on the IP group resource instead of making changes in every single rule in your firewall, right? So the news here is really about the new limit. We had a lot of feedback from customers saying, hey, 100 IP groups is not enough. We have a a complex environment, so having at least the double of this limit would be great. And that's what we came up with. So 200 new 200 IP groups per single Azure Firewall deployment. This information is already available in our public documentation as well. So if you take a look at the Azure subscription limits and quotas, you're going to find these new numbers as well. Okay, then we have the parallel IP groups, which is also another announcement that was made yesterday. The parallel IP groups, when we are using IP groups, at least previously, that was the behavior, right? If you had more than one IP group being used in the same Azure policy, you were not able to make parallel updates on these IP groups, because it would fail. The changes would need to be, first one IP group. Once it's done, you start making the changes on the other IP groups. So right now, we just announced the parallel IP groups updates, where you can, update up to 20 IP groups at a time. Again, this is if you are using these up to 20 IP groups in a single Azure policy, right? So now you will be able to make the updates up to 20 IP groups that are attached to a single Azure Firewall policy. These updates on the time taken to make these updates will depend on how many changes you are making, how many IP addresses you have in each one of these IP groups, but you don't need to do one to start doing another until you complete all the IP group updates. So it's really time saving for everybody who's managing Azure Firewall and Azure Firewall rules. It helps with not only if you were doing this through the portal, but it also helps for the people who's doing Azure Firewall management using infrastructure as a code. And that's one of the features that we've been receiving from customers for a long time now. Since it's a public preview feature, you need to go through you need to activate the provider. You can activate the provider in two different ways. You can do it through the portal, or you can do it using PowerShell. Um, if you want to see exactly what command you need to run in PowerShell, we have the link here in this slide. This slide deck will be available later for everybody for everybody, so you can get the link here. If someone on the team can just paste the link in the chat, it would be helpful as well. Thanks. Then the next one is also a change in our backend, but that we've been receiving feedback about this for a long time as well. So just to bring some context here, previously scaling process was only based on CPU and throughput. And so what happened is that Azure Firewall would gradually scale out when the average throughput and CPU consumption was at 60%. We haven't changed that. So for throughput and CPU, we keep the same. So when the overall consumption gets to 60%, we're going to start scaling out and deploying new instances behind the scenes. But now we are also having another threshold, which is for number of connections. So if you have your threshold and CPU consumption at 60%, we start scaling out. And if your connection usage is at 80%, we also start scaling out, right? Just a reminder that scale out processes, the process takes 5 to 7 minutes to complete. And the update here is that for the scaling process, both for throughput, CPU, and connections, we start scaling process when it's below 20%. So this is a new feature. Again, it's not something that's available in the portal, or not something that you can change the settings by yourself. This is just a new improvement that have been made on Azure Firewall. Throughput, CPU, and number of connections. And the last feature that we have to talk about here is a feature that's currently in public preview. So we are talking about the auto-learn SNAT with route server. And first, it's important to understand what's a route server. So the route server is a fully managed service that enables dynamic routing between your networks, virtual network appliances, and the Azure network, Azure Virtual Network, without requiring manual configuration or intervention. It uses BGP routing protocol to exchange routing information with any NVA that supports BGP. And why is this feature really important? So some Azure Firewall customers have challenges when they need to configure non-RFC 1980 address spaces to not SNAT through Azure Firewall. And this can cause issues with routing, connectivity. And then to address this problem, Microsoft has added a new feature that allow customers to specify which address spaces should not be SNATed, right? So helping reduce the overhead of managing custom routes and net rules. So this auto-learn SNAT with route server is a new option available when you are configuring SNAT on Azure Firewall. As I said, it's currently in public preview and can help reduce time and complexity spent manually, defining SNAT private ranges. When you have the configuration in place, the Azure Firewall will pull an updated list of learn addresses ranges from the route server every 30 minutes. And these learned addresses ranges are considered to be internal to the network. So traffic to destinations in the learned ranges are not going to be SNATed. This is just how the configuration looks like. As I said, it's a new option within the SNAT configuration in Azure Firewall. Andrew will walk us through these configuration steps in the demo. So with that, we finish the discussion about the new feature releases for Azure Firewall. Then, Andrew, can you start sharing your screen and do the demo?
Absolutely. Thank you, Gustavo, for that walkthrough. Let me just start sharing my screen. I hope you can be able to see this.
Yeah, I can see it.
Perfect. Thank you. So in this next section, we'll go through some of the features that Gustavo has highlighted as part of what's new in Azure Firewall. So first of all, you're going to begin with the embedded Azure Firewall workbook. So with this workbook, it offers you a flexible way to see all your Azure Firewall events and be able to query and represent them in a visual representation through charts and graphs. So to begin us off, we actually do need to have data that is being collected, that is logs from the Azure Firewall. And like Gustavo mentioned, we need to activate the resource-specific logs, or rather the structured logs. So you can see here, I'm in an Azure Firewall instance. If you go down to monitoring, you'll see here the workbook, and this is the new embedded workbook. But before we start using this workbook, we actually need to start sending logs to our log analytics workspace. So here under diagnostic settings, still under monitoring, you can see there are a couple of settings that have been put in place. So if I click here on the last one, we'll see what's happening. So you need to select which logs you need to send to the workbook, so you're able to see all the Azure Firewall events that you want to query. And once you've selected here on the left, you'll select the resource specific table. So this is actually a requirement for this embedded workbook to work. Then once that is done, if you go back to workbooks, you'll see a couple of tabs, and this second tab here called Azure Firewall Structured Logs. This is where now the workbook is located. I'd already opened one, so I'll just click on that. As that opens, I'll quickly jump to the one I had opened, and this is how our workbook looks like. So we'll see at the top a couple of tabs. We have overview, application rules, network rules, DNS proxy, IDPS, threat intelligence, and investigation. So with this, you do get a consolidated window where you are able to analyze your Azure Firewall events. And now that it's embedded, it's actually very seamless and easy to use. So under the tabs, you can select your time range, the workspaces, the files which are sending this data. And now within the actual workbook, you'll be able to see the various data that you can use to query. So beginning with the overview tab, this is showcases the graphs and statistics that are related to all types of firewall events. And these are aggregated from the various Azure Firewall logging categories. So you'll be able to see events by time, by category. You can also be able to see the average throughput of the firewall traffic, as well as the SNAT port utilization. You can see the network as well as the application rule hit counts. The second tab is the application rules tab, and this shows the layer 7 or application layer related event statistics correlated from your specific application rules in the Azure Firewall policy. So here you can be able to see denied FQDNs over time, the application rule usage, denied FQDNs by count, and this will now give you the visibility into what's happening as based on your application rules. We also have the network rules tab, and under this, I'll be able to see the network or layer 4 related event statistics. So you're able to see the target ports, the DNAT actions. I also have a chart here for geolocation. And down here, you can also be able to see further counts as well as graphs. If your Azure Firewall is a DNS proxy, that is, it's serving as an intermediary for DNS requests, you're also able to see that related information. So you'll be able to see DNS proxy traffic by count per firewall, DNS proxy count by request name, and also by the client IP. We also have the IDPS tab, and within this tab, you're able to see a summary of all the malicious traffic events as well as the preventative actions that were taken. So this, of course, is aggregated if you have IDPS enabled within Azure Firewall Premium. So you'll be able to see, for example, even in terms of which signatures had the most hits. You'll see the source IPs filtered also by destination IP. Then you also have Azure Firewall IDPS count over time. So this is a great tab to really see in terms of malicious activities that are being caught by Azure Firewall IDPS. Then we also have the threat intelligence tab, and like Gustavo mentioned, this is a new tab that was recently added, and this one will spotlight the most prevalent threats, the actions, the protocols, so you're able to see a view in terms of what is coming in through the threat intelligence if you've enabled it within your Azure Firewall. Finally, we also have the investigation tab, and this one is used for exploration and troubleshooting. So you'll get more details in terms of the virtual machine name, the network interface name that are associated with the initiation or the termination of traffic. So this you're able to drill down and be more specific and granular. And you can see here they're also grouped in terms of FQDN traffic by count, the source IP addresses, the source lookups. Also have here an FQDN lookup log. So with this, you're able to, like I mentioned, really go down, drill down, and be able to investigate if the event that you want to isolate or be specific. So that's about the Azure Firewall Embedded Workbook. Again, a great resource for you to really know what's happening within your Azure Firewall instance. And all of this is aggregated within this specific workbook. So a great resource and a good addition to the Azure Firewall. So next we'll take a look at the flow trace logs, and I'm going to go to this new window. So the flow trace logs, like Gustavo also mentioned, these logs are here to basically help us to troubleshoot Azure Firewall traffic, Azure Firewall flows. Initially, what used to happen within the Azure Firewall in the network, if you use the networking logs, you're able to see the first packet that flows through the Azure Firewall. That's the SYN packet. So with that, what it means, you won't be able to see, you are not able to see the other subsequent flows that used to, that probably would have come or used to go through the Azure Firewall. So what the flow trace logs essentially has done is it has given us more visibility into what's happening in terms of our flows. And it's a great tool for troubleshooting, as we'll subsequently see. And then also just to note, like was also mentioned, to avoid excessive disk usage, this is recommended to use only when you're troubleshooting a specific issue, of course, for diagnostic purposes. So to set up the flow trace logs, again, you'll go to your Azure Firewall instance under diagnostic settings. There are a couple of prerequisites that you need to do first. And here, if we go to our diagnostic setting, if I edit it, you'll see here I've selected my logs, and specifically down here, you'll see the Azure Firewall flow trace log. So this is the first thing that you need to do. And then in terms of where you're sending these logs, you need to send them to the resource specific table. So under the destination table, you'll select resource specific, as this only supported in this new logging format. So once you've done that, the next step, I'll click here on this tab. You're actually able now to see, like I mentioned, the other packets with their flags. And this is pretty simple. Once you go to the Azure Firewall or your log analytics workspace, you go to logging, you'll be able to type in this KQL command here, the azfw flow trace, and you can also use other parameters if you also want to filter or to group. So in our case, as you can see here, these are the flow trace logs that you're currently seeing. And there are a couple of flags you can see here. I think this is the 5th column, and these show us the various additional flags that we were previously not able to see. So you have the SYN arc. This is for acknowledging the SYN packet. You have the FIN. If the original packet flow is finished, we have the FIN arc, which also shows us an acknowledgement of the FIN packet. The resets, in our case here, I don't think there's a reset flag recently. And then we also have the invalid flags. And these invalid flags are very particularly useful when it comes to troubleshooting. So of course, for invalid, it means it could be as a result of maybe a bad checksum. It could also be a result of an overly delayed maybe acknowledgement packet. And of course, it could also mean there's an issue, as was mentioned, probably of asymmetric routing. So we can use these particular logs to troubleshoot our environment in the event that an issue arises. In our case, we had set up already something to check on the asymmetric routing. I'll just go to the next tab and then also show you our setup. So here we have a couple of virtual machines. We have a server machine, virtual machine client, and an Azure Firewall. So what happens, this server 10054 sends traffic directly to our client server, but the client server does not reply directly to the server. The traffic goes through the Azure Firewall. So what this means is that the Azure Firewall is not seeing this first subsequent packet, that's the SYN packet. It's only seeing the SYN arc. And this, of course, you know, causes asymmetric routing. So if we go back to our logs, you see here already filtered AZ flow trace where flag is invalid. And you can see here in terms of what this shows us based on that small architecture that I showed you. So here we have our client machine. We were actually trying to RDP from the server machine, that's 10054. This goes directly to 10035, but the return traffic doesn't go back directly to the source. It goes through Azure Firewall. So Azure Firewall only sees the SYN arc, and this is now flagged as invalid. So this is one of the use cases that you can use for troubleshooting if you have issues, if you are seeing drops, if you suspect asymmetric routing. So a very good addition, and we know this is extremely useful for everyone out there who uses and administers Azure Firewall. So great. So with that, the next one we'll take a look at is the resource health. So this resource health has now been added to Azure Firewall. And with the resource health, you're now able to know the health status and also see if there are any service problems within Azure Firewall. So resource health was there within the Azure portal for other resources, but it wasn't there for Azure Firewall. So another good addition. In my case, you can see in terms of the status, the health history, it's showing all green. We haven't had any major issues showing available, but we do have other states such as unavailable and non-degraded, and this can show you if you have an issue within your Azure Firewall resource. In addition to this, showing us the status, you can also add a resource health alert on this tab here. So what this will do, it will allow you to create alerts in the event that the status of the files changes. And of course, with action groups and automation, you can even be getting emails or SMSs, notifications if there's any degradation on your Azure Firewall. So this is on resource health. Again, you'll find it within your Azure Firewall instance if you scroll down on the left under help. The next one we'll take a look at, and this one really we can't really demonstrate, but again we'll try and go through it. This is for the IP groups, we saw two announcements there, like Gustavo mentioned. The first one is in terms of the parallel IP group updates. So you can update 20 IP groups at a time of a file instance. And then we also had, in terms of the increase of the IP groups for an Azure file. So within an Azure file, you can have up to a maximum of 200 IP groups. So an IP group is basically, as you can see, it's a container or a top level resource that allows you to define IP addresses, IP address ranges, and subnets into a single object. So in our case, this is the name of our IP group. And under settings, IP addresses, you can see the various IP addresses that are within this IP group. So you can use IP groups within the Azure Firewall Modena tools, within the source, in the network rules, in the destination as well as the source, and in the application rules as a source address. So it's basically a container where you'll have, like I mentioned, IP addresses, ranges, that you can also reuse within your Azure Firewall policy. Just as an example, you'll see here, there's one here already opened. We are using this DDoS solution IP group with these IP addresses within one of our network rules. So in terms of the updates that have been announced, you can now be able to update 20 IP groups simultaneously. This was previously not there. You had to go and update one IP group at a time. And then also in terms of the increase in terms of the maximum IP groups, there are now 200 per file. So some good additions in terms of your Azure Firewall administration when it comes to the IP groups. And then just to mention how you can activate it, you can either do the parallel IP group update either through PowerShell. You can come to preview features and make sure that it's registered. So I'm just showing this from the Azure portal in terms of if you want to start using and maybe testing this feature. So you'll just go to preview features and then search for the Azure Firewall parallel IP group update. So that's in terms of the IP groups. The next one we'll take a look at, last but not least, is for the auto LAN with the root server. This was also mentioned by my colleague Gustavo. So this is again a very good addition, as we've had customers facing challenges and they need to configure non-RFC 1918 address spaces to not SNAT through the Azure Firewall. So this was causing issues with routing, connectivity, and also with performance. So what has happened to address this issue? We've had an integration of Azure Firewall with the root server, and with this, the root server is now able to teach or to share, you can call them IP addresses ranges with the Azure Firewall, and these now are exempted from the SNAT on the Azure Firewall. So with this feature, it will help us to reduce the overhead in terms of managing custom routes, NAT rules. It will also improve the efficiency and reliability of the network traffic. So to begin off, in terms of the setup, this is actually explained in a great blog, which one of my colleagues wrote. So if you do have time, let me just see if I had it open here. Yes. So this blog explains how this setup is done. We have a great example, and which we are also going to use within this demo. It was recently written late last year. So with this, you can see this diagram. Let me see if I can make it a bit bigger. Seems it's not accepting. But basically, in this setup, what we have is a simulation of a customer environment. So here on the right, we have a remote network, a third-party NVA, our root server, and our Azure Firewall. So what's happening? These remote networks are being launched by our third-party NVA, which is paired, BGP paired with our Azure root server, which again is paired with our Azure Firewall. So the Azure Firewall is able to learn these IP addresses, even when they're coming from this remote network. And this setup, the Azure Firewall is able to know how to treat these IP addresses and not use them for S-NATing. So I'll go back to our setup here. So what we have, first of all, you'll need a root server. In our case, our root server is called RS OPN VNet. If I go to it, you'll see here, if it comes up under peers, we've paired it with our NVA, so it's able to learn the routes. So after that is done, the next step, once this is set up, and there's actually a very good quick guide start on how you can do the initial setup, especially on this root server pairing with the NVA. So once this is set up, the next step is to go to our Azure Firewall. So within our Azure Firewall instance, if you go to settings and then land SNAT IP prefixes, you'll be able to see this page. So initially, what you need to do is to select a root server. In our case, our root server has already been selected. But in the event that you come here the first time, you'll need to select a root server. Once you've selected it, you'll add it here. This next step is to now enable this on the Azure Firewall policy. So this enabled here will actually be disabled. So once you click on it, it will take you to your Azure Firewall policy under the private IP ranges SNAT. Once you're here under this private IP ranges SNAT, you're going to select auto-learn IP prefixes, and this will now enable the sharing of these routes between the Azure Firewall and our root server. So the root server updates the Azure Firewall every 30 minutes. In our case, we've already done this a bit earlier. And if we go back under the land SNAT IP prefixes, under land IP prefix, you'll see we've learned these IP addresses ranges. So these are actually from our remote network. This went through the root server, then finally to the Azure Firewall. So you can see here we have two of them. One is public, the other is private. So this is a great addition for Azure Firewall, especially when it comes to the efficiency and also the handling of SNAT traffic, which used to cause some bit of issues in the past. And with that, this is now our last demo. I'm going to stop there and hand it over to our moderators, Valon, in case there's any question. We are happy to take and also wrap it up. Thank you.
Well, thank you, Andrew, as well as Gustavo. There's surely been lots of questions coming in as well as answered, but we can sure address some of them here with you and elaborate a little bit further on them. So here goes the first one. For any communication between two Azure firewalls across subscriptions in Azure, do we need to configure VPN IPsec between them?
That's a good question. No, we don't need to configure IPsec VPN in between them. So for Azure Firewall, they're deployed within the VNet. For example, we have the famous hub and spoke. So if you have an Azure Firewall, probably within a hub VNet, another Azure Firewall as an example in a spoke VNet, all you need to do is configure your routing, and they should be able to communicate with each other. And by routing, I mean the UDRs, the user-defined routes. So IPsec VPN is not mandatory.
Yeah, just one thing to add here. You know, if the VNets are not in the same subscriptions, or even if they are like different VNets, you need to have some communication or some connection between these VNets, right? And there are some different ways to accomplish that. VPN would be one of them, because the VNets, when you create them, they are isolated from each other. So if you have resources living in different VNets, you need to create a connection. So VPN is one of the options. You can also use VNet peering, or you can also use connections via ExpressRoute, or you can also use vWAN for that. So there are different options to connect to connect VNets, either in the same subscription or different subscriptions. But that's not a requirement to have traffic between Azure Firewall being sent, from one to another. I mean, VPN is not required. You can use either one of the options available today.
Okay, well, thanks for that answer. And I have another question which comes in two folds. Which table you recommend for storing the firewall logs? Is it the Azure Diagnostics or resource specific? And then the follow-up to that one is, can we switch to resources specific from Azure Diagnostics when the firewall is in the production? And if we do so, will there be any impact on the production?
Yeah, I can take that one. That's a pretty good question. First thing, yes, we do recommend moving from Azure Diagnostics to resource-specific logs. And the reason why is not only because the resource-specific logs has a better schema, which, helps you understanding the logs without need to parse to parse it. But you can also save some costs when you are using the resource-specific logs. We do have a blog post in our tech community which shows the difference, the cost difference when using Azure Diagnostics and resource-specific logs. I think someone on the team has posted that in the chat. But yeah, I recommend taking a look to see the differences there. And then for the second question, when by enabling the logs, it should not affect Azure Firewall at all. So we do see a lot of people enabling logs, in firewalls that are in production. You can definitely switch from Azure Diagnostics to resource-specific logs. It's just a matter of making the changes on the diagnostic setting configuration. You can also have both enable at the same time. The thing is that if you have both, you're gonna be sending maybe duplicate logs to different tables and paying more to store this data. But you can definitely do that. However, there's a thing to consider. A lot of customers have their, governance in place that requires that any kind of changes just happen under the maintenance window. So then, even though it's not expected to affect production or performance, it's really important to see what's the policy that you are following to know if even this small configuration would need to have a maintenance window or not.
Thanks, Gustavo, for that. Next one goes, how does the IDPS signatures monitor encrypted traffic? Does the firewall decrypt the traffic for monitoring both ingress and egress traffic?
Good question. You can go ahead.
Yeah. So for IDPS, for you to see the encrypted traffic, you'll need TLS inspection, and this is available in Azure Firewall Premium. So with TLS inspection, it's able to decrypt the encrypted traffic. IDPS will inspect this traffic based on its signatures. And if there's any malware, if there's any attack, it's going to drop it. So this is how it's able to can say view and also stop attacks within encrypted traffic.
Thanks, Andrew, for that. Okay, the next one is, how do we take backup of Azure Firewall policy and restore it to previous state?
I can take that one. We don't have like a native solution, like a button in Azure Firewall Portal or a command that you can run to do a backup. But there is a solution, a playbook solution in our tech community blogs that you can find it, a playbook to help you take the backup and restore configurations on your firewall policy in your Azure Firewall. So even though it's not a native solution, it's a supported solution, which is publicly documented in our blog posts, and it's available for anyone who wants to implement it and start using it.
Thanks, Gustavo. And the next one is the route server mandatory for functioning of Azure Firewall?
No, that's not a the route server is not mandatory for the functioning of Azure Firewall. You only need to have the route server if you want to implement the auto-learn SNET integration with route server, right? So let's say if you want to make the SNET configurations by yourself, you have the option in Azure Firewall, so you can do it manually. But then if you want to use the integration and then have the learning process automatically implemented, then you can you need to follow the steps to deploy the route server and do all the configuration that Andrew has demonstrated here today.
Okay, thank you for that. That was the last one I had on my list, but I thought I saw some couple more coming in. Let me just check. Although I see that the rest of the SMEs here are helping with answering. And how do we set up collecting the logs other than diagnostic settings?
Can you say that again? Sorry, I didn't
no
catch
problem.
it.
How do we set up collecting the logs other than diagnostic settings?
You could use, there are different options. You can send, all the options are through diagnose settings, right? So today, if you want to have access to Azure Firewall logs, you need to have some kind of Azure diagnose settings enabled. You can change the destination, so you can send the logs to a storage account, to a log analytics workspace, or to Event Hub, but it has to be through the diagnose settings. Other than that, there is no option for you to collect the logs from Azure Firewall.
Okay, and let me check. Thank you for that, Gustavo. There's more coming in. Okay, I have an application where customers can upload the files to Azure Storage Blob. This is in Azure Government, and here there is no defender for storage. Malware scanning not available. Can I place an Azure Firewall in front of the storage account in order for malware scanning of files to be uploaded?
Want to take that one, Andrew? Or
I can take it. So, Valon, could you repeat the question again?
Sure. So there's a scenario where an application where a customer can upload files to Azure Storage Blob. So this is in Azure Government, and there is no defender for storage. That is for malware scanning. It's not available. So the ask is, can I place an Azure Firewall in front of the storage account in order for malware scanning of files that are being uploaded?
That's for Azure Storage. Not too sure on this. Gustavo, do you want to take a shot at this?
Yeah, I think the closest answer to this, it really depends on your deployment, right? So let's say, for example, if you have your applications running on IaaS VMs, right? And then you have the Azure Firewall in front of VMs. So all the outbound traffic from the VMs to the storage accounts could be inspected. So you could apply TLS inspection and IDPS. So all the outbound requests coming from those VMs to storage accounts would be inspected. But then, and then you can use that, either using storage accounts public endpoints or using private endpoints. So you can also use the Azure Firewall to inspect the traffic that destined to private endpoints. But then you see that the configuration here is really putting the Azure Firewall in the middle of the path, on the outbound path of that VM, and not really in front of the storage account. So let's say, for example, you have applications coming through internet to the public endpoint of the storage account, and you want to put Azure Firewall in front of that, then that's not possible. So that's why we would need to get more understanding of the scenario. But if you have ISVMs applications running on Azure, yes, you can have Azure Firewall in front of the in the outbound traffic to the storage account. So all the outbound traffic from the VMs will be inspected. But if you want to have the Azure Firewall in front of the storage account doing the, inspection of internet traffic, then I haven't seen that deployment.
Got it. Thank you. And the last question goes, because we are here over 5 minutes over time, how to move the firewall logs, which is older than 90 days, to a storage account for governance purpose? Is if it's possible, can we automate the process of moving logs?
I haven't seen a solution for that yet. I know you have the configuration where you set the how long you're going to store the data in the log analytics workspace. But I'm not sure if there is an integration between storage log analytics workspace and the storage account, so you can move the data between them automatically. That we would need to follow up on that if that's possible.
Well, thank you, Gustavo and Andrew, for being our guest today and for sharing this great information with our community. Also, would like to thank our SMEs who helped us with answering the questions and providing the resourceful information while the presenters were presenting. And to all the listeners still on the line, if you're someone who wishes to aid in protection of the world from cyber threats and desires to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community, because together we believe that we can make a global impact. So please join us at aka.ms/security community. This is also the place where you'll be notified about the upcoming webinars, such as the one we had today, other security events and announcements. Also, please take a minute to submitting your webinar feedback at aka.ms/security webinar feedback. For those of you that may have additional questions on the topic we just covered or other product related questions, please feel free to raise them on our Microsoft Tech Community discussion space. And for the network security space, the short link for that is aka.ms/ANS community. Thank you all for being part of our community and for joining us on these webinars. So we hope to see you next time. Goodbye.